All right, let's get right into it. Today, we've got a real cosmic detective story for you. The victim? Well, you could say it's our entire understanding of the universe. The main suspect? None other than Albert Einstein's greatest theory. And the clues? Well, that's where it gets weird, because they seem to be everywhere and nowhere all at once.
And here's the mystery at the heart of it all. Einstein's theory of general relativity is without a doubt one of the most successful theories in all of science. It works with stunning precision. So why, right? Why is it that when we look at the big picture, the whole universe, the math only seems to account for about 5% of what's out there? Where's the other 95%?
And that right there is what you might call cosmology's dirty little secret. To make our very best theory of gravity actually work on a cosmic scale, we've had to invent some pretty big patches. And it kind of makes you wonder, doesn't it? If a theory needs that much help to match what we see, is it really a successful theory, or is it pointing to something fundamentally broken?
So these are the big ones, the ghosts in Einstein's machine. We're going to focus on the two main culprits today, dark matter and dark energy. These things represent massive, unexplained gaps between what general relativity predicts and what our telescopes are actually telling us. We can't see them, can't touch them. But here's the kicker. Without them, the universe as we know it would just fly apart.
Okay, so before we point any fingers at Einstein, we have to do our due diligence, right? We got to establish the alibi. Why on earth do physicists trust general relativity so much in the first place? Well, let's look at the evidence where it works. Perfectly. And look, on what we call local scales, think our solar system, general relativity is not just good, it's scary good. We're talking correct to parts per billion. That GPS in your phone literally wouldn't work without it. The theory predicted black holes existed decades before we took a picture of one. And in 2015, we heard the sound of space-time ringing like a bell from two black holes crashing together. And the sound was a perfect match for Einstein's equations. Just incredible. This really gets to the heart of it. It's like having one single ruler, just one, that can measure the thickness of a human hair and the distance to the moon with the exact same flawless accuracy. I mean, that's just a mind-blowing level of precision. That's the theory we're dealing with.
Okay, alibi established. General relativity is an absolute rock star. Now, let's head to the scene of the crime. We're zooming out from our little solar system to the scale of entire galaxies. And this is where that perfect ruler suddenly seems to shatter. And this is where scale becomes everything. You see that supermassive black hole M87 star? That's a place where GR is king. It's like a single grain of sand. But the galaxy it lives in? That's a whole cosmic beach, millions and millions of times bigger. And it's out there, on that beach, that all the trouble starts.
So here's the problem. You look at a galaxy spinning, and the stars way out on the edge are moving just as fast as the ones in the middle. Think about a merry-go-round. If you're on the edge and it spins too fast, you get thrown off. Well, based on all the stuff we can see, all the stars and gas, there is no way there's enough gravity to hold on to those outer stars. They should be flying off into the void. But they're not.
So that leads us right to the big question, this central debate. We've got our crime scene, and we've got two main lines of inquiry. Is there an invisible accomplice out there providing the extra gravity, or is the law itself just wrong? To really get it, you gotta look at Einstein's big equation. Don't worry, it's simpler than it looks. Think of it this way. The left side is about the shape of space, basically the rules of gravity. The right side is all the stuff in the universe, matter and energy. So, if the equation isn't balancing out, the problem has to be on one side or the other.
All right, suspect number one, the invisible accomplice. This idea says, hey, the left side of the equation, Einstein's rules for gravity, is totally fine. The problem is on the right side. We're just not counting all this stuff. It's saying the universe is packed with invisible material, dark matter and dark energy that's providing all that extra gravitational glue.
Then you've got suspect number two, a flawed law. This theory, sometimes called modified gravity or MOND, says the exact opposite. It says, nope, we've counted all the stuff just fine. The problem is the left side. Einstein's math, as brilliant as it is just a little bit wrong, or at least incomplete, when you get out to these huge cosmic scales. For decades, this was a huge debate. Both sides had good points. It was a real head-scratcher. But then, astronomers stumbled upon a clue, a piece of evidence that, for many, was the smoking gun.
Let me walk you through it. What you're seeing is the aftermath of two entire galaxy clusters smashing into each other. Now, the normal matter, that hot gas you see in pink, it collided, slowed down, kind of got stuck in the middle, just like you'd expect. But here's the crazy part. Astronomers used a trick called gravitational lensing to see where most of the gravity was. And that gravity, shown in blue, just sailed right on through. It completely separated from the stuff we can see.
So think about what that means. The gravity is over here, but the visible matter is over there. They're not in the same place. If gravity only came from the stuff we can see, that would be impossible. It's like seeing wet footprints tracking through a room, but the person who made them is standing way over in the corner. You know, something invisible must have walked through that puddle.
And that discovery brings us to the verdict. Well, the verdict for now anyway. The case isn't completely closed, but that evidence from the bullet cluster, it has most physicists leaning very, very heavily towards one of our suspects.
Basically, physicists are going with what you could call the least broken option. I mean, think about it. Saying that 95% of the universe is made of some mysterious stuff we've never detected, that is a huge claim. It's a tough pill to swallow. But the alternative, trying to rewrite gravity itself, just can't explain the bullet cluster. So for now, we're betting on the ghost. We're betting there's a particle out there we just haven't found yet.
And this is the result of that bet. This is our universe. Everything you see, everything you've ever heard of, every star, every planet, you, me, all of it. That's the tiny 5% sliver of normal matter. The rest? It's this bizarre cocktail of dark matter holding galaxies together and dark energy pushing the whole universe apart.
So, that's where we are, standing at a massive crossroads in physics. Will we finally find the ghost in the machine? Are we on the verge of detecting these dark matter particles and proving Einstein was right all along? Or is there another clue waiting out there? Another observation that's going to force us to tear it all down and rewrite the very laws of the cosmos? The investigation continues.